Hi, I am Lopamudra Sen. Welcome back to my channel Electronic Science Tutorial. I have already discussed some important topics of digital electronics in my channel. From previous class, I will start some other important topics of digital electronics like canonical expression in my channel. Those who are not subscribe my channel but follow my channel, please do like, share and subscribe my channel. It will encourage me. So please like, share and subscribe my channel. सब्सक्राइब की बेल आइकन को प्रेस करके रखिए ताकि जब भी मैं कोई नई वीडियो लेकर आऊँ आपको पता चले. So let's get started. In today's class, we talk about the Shannon's expansion method for canonical expression. So, what is Shannon's expansion theorem? According to this theorem, which we can be applied for the purpose of conversion of any function either to the canonical SOP or to canonical POS form. In today's class, we talk about how we get canonical SOP form by using Shannon's expansion technique. So, let's start our class. Our first example is express the function f which has a three variable function xyz that is equal to xy plus yz into canonical SOP form using Shannon's expansion technique. So by using Shannon's expansion technique, how we get a canonical SOP form, here we saw. This function f has a three variable function. According to Shannon's expansion theorem, how this three variable may be written? So in this way, that is f function of xyz that is equal to x bar y bar z bar function of 0 0 0. Why this is x bar y bar z bar? Because according to SOP form we know that is 0 is represented by complemented variable and 1 is represented by single variable. So because of this reason xyz is represented by x bar y bar z bar because it is a function of 0 0 0 plus next term is x bar y bar z. It is a function of 0 0 1 plus x bar y z bar. It is a function of 0 1 0 plus x bar y z. It is a function of 0 1 1 plus x y bar z bar. It is a function of 1 0 0 plus x y bar z. It is a function of 1 0 1 plus x y z bar. It is a function of 1 1 0 plus last term is x y z. So this is a function of 1 1 1. So in this way we can written the three variable function by using Shannon's theorem. So now we saw that is what is the value of this function, that is f 0 0 0, f 0 0 1, f 0 1 0, f 0 1 1, f 1 0 0, f 1 0 1, f 1 1 0 and f 1 1 1. Okay. So the next step is to find out the functional value of this term. What is the given function? That is xy plus yz. So by using SOP form, we can consider this function in this way, that is here, just a minute. In the first term, z variable is missing and in the second term, x is missing. So how we can represent this expression by using SOP form, that is xyz plus x y z bar plus xyz plus x bar yz. So in this way we can write the expression. This term and this term is common in these expressions. So how we can minimize this expression, that is xyz plus x y z bar plus x bar y z. So this is 1 1 1. So how we can represent this xyz, that is this is the function of 7, this is 1 1 0. So this is the function of 6 and this is 0 1 1. So this is the function of 3. So 7 6 3, right? 7 6 3, this term may be present in this expression. So what is the functional value of f? That is f0 0 0 is equal to 0 because this term is missing. f0 0 1, that is x bar y bar z, this term is also missing, so here we write 0. f0 1 0 means x bar y z bar, this term is also missing, so here we write 0. Next line f0 1 1, that is x bar y z. So this is present in this expression. This is maybe present in this expression. So here we can consider 1. Next f100. So this is the value is this value is x y bar z bar. This term is also missing. So here we write 0. f101, that means x y bar z. This term is also missing here. So here we write 0. Next f110. 110 means x y z bar. So x y z bar is also present here. So here we can consider 1 here. f111, that means x y z. This is also present in this expression, may be present in this expression. So here we can consider 1. So this is the functional value of f. So from the functional value of f, how we get the Shannon's, how we get the canonical SOP form? Hence we can write that f, which is a function of xyz variable, that is equal to x bar y bar z bar. Its functional value is 0. So here we write 0 plus x bar y bar z. Its functional value is 0. So here we write 0 plus x bar y z bar. Its functional value is also 0. So here we write 0 plus x bar y z. Its functional value is 1. So here we write 1 plus x y bar z bar. Its functional value is 0 plus x y bar z. It is also 0 functional value plus x y z bar. It is 1 functional value. So here we write 1 plus x y z. It is also 1 functional value. So here we write 1. So what we get? This term is product with 0. So we get 0. Next this term is multiplied with 0. So here we get 0 plus this term is multiplied with 0. So here we get 0 plus this term is multiplied with 1. So here we get x bar y z plus next two term is also multiplied with 0. So here we write 0 plus 0 plus x y z bar plus x y z. So what is the function? What is the decimal notation of this canonical SOP? That is summation m 367. So this is the canonical SOP form which we get by using Shannon expansion technique. Okay, it's very easy. If we solve this expression, or if we understand this expression in this way, it is very easy. Okay, so here we end today's session. Thank you. If you like my video, then please like, share and subscribe my channel. फिर मिलते हैं एक नए वीडियो के साथ. Thank you.